Alright, this video is about how to solve trig equations, and sometimes we have to use trig identities, and I'll show you what we do here. So it's the same directions you've been given all along, where you're finding x, which is the angle where a certain value occurs in the unit circle between 0 and 2 pi, just one revolution. Now, this is kind of what happens when you have two different trig ratios introduced in the equation. You have cosine and sine. We have to have the same trig function, otherwise we can't solve it. Okay, so what we're going to do is use our trig identities to help us do that. Now the first thing I'm going to do is move that sign over here. So I'm going to have cosine x, or cosine squared x minus sine squared x, okay, equals 0. Now I'm going to use my good old trig identities. I know that cosine squared is 1 minus the sine squared x. So I'm going to substitute that in and just bring the minus sine squared x right down. Okay, so what do I have? 1 minus 2 sine squared x equals 0. This is something I can solve just like I did before. So I'm going to subtract 1 from both sides. Negative 2 sine squared x equals negative 1. Divide by negative 2. So what I have is sine squared x equals, this will be positive 1/2 because they're both negative. So I'm just going to move this up here for more space. So sine squared x equals positive 1/2, but it's squared, so I got to take the square root of both sides, right? So I get the sine of x equals plus or minus. When I do that, I get 1 over the square root of 2, right? But you have to rationalize that, which gives me the square root of 2 over 2. So it's plus or minus square root of 2 over 2. So think about where are the y values, square root of 2 over 2. That's your pi over 4 angles all the way around, because I need positives and negatives. So my answer then are my pi over 4s going starting from lowest to highest. So I go pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. So this answer has 4 solutions. 2. Look, again, you have two different trig ratios. We've got to get rid of one and get to the other one. So I'm going to go for the cosines this time. All right, sine squared we know is 1 minus cosine squared, right? So I'm going to substitute that in, and I'm going to move that 3 over. All right. So if I do that, 1 minus cosine squared x plus 3 cosine x minus 3 equals 0. All right. Now I want to distribute that 2. So 2 minus 2 cosine squared x plus 3 cosine x minus 3. And let's combine like terms. When we do that, I get negative 2 cosine squared x plus 3 cosine x minus, 2 minus 3 makes it minus 1, right? Now, notice that the squared term is a negative coefficient. We don't want that, okay? So we're going to change all the signs so the lead is positive. Okay? So as long as you change all the signs, it's okay to do that. So now I have positive 2 cosine squared x minus 3 cosine x plus 1. Alrighty? Now we're at a place we can just factor. So think of it as 2x squared minus 3x plus 1. Alright? When numbers multiply to give you a 2, but add to give you negative 3, well, negative 2 and negative 1, right? Do the box method. So negative 2, negative 1. Greatest common factor would be x. This one would be minus 1. This is 2x, and this is a plus 1. Or no, I'm sorry, this is minus 1 as well. So now I bring them back and put the cosines in. So I get 2 cosine x minus 1 equals 0. And then I'm going to have cosine x minus 1 equals 0. So now we solve these two individual mini problems, okay? Move the 1 over. So I'm going to end up with cosine x equals 1. Divide both sides by 2. I get positive 1/2. Over here, cosine x, if I move the 1 over, is just positive 1. So where are the cosine values? Positive 1/2. Well, That's at pi over 3 and 5 pi over 3. Where's the cosine positive 1? Well, that's just right here. That's where x is 0. So put your answers now in order from 0, pi over 3, 5 pi over 3. All right, there you go. All right, next problem. Again, we have two functions going on. We need to substitute one of our identities in to get rid of one, get them all the same thing. They're on one side, thankfully. I can look at my identity chart and see that 1 plus tangent squared x is secant squared x, right? So I can quickly substitute that one in and get this solution. Now this is just a greatest common factor deal. They both have a secant, so I'm going to factor out a secant. And what I have left is secant x minus 1 equals 0. Now I said each of the two factors equal to 0. So secant x equals 0. Secant x, equal, secant x minus 1 equals 0. Now we have two separate things to solve. So let's secant and a reciprocal, right? What's it the reciprocal of? Well, reciprocal of cosine. So I'm going to flip this side. I got to flip this side. Well, if this is 0 over 1, if I flip it, it's now undefined. So we're asking, where is the cosine undefined on our unit circle? Right? Well, if you think about your unit circle, there is nowhere on there that there's not an x value. So this is not even a solution. It doesn't help us. However, over here we can solve this. Secant x, if I move my 1 over, I get a 1, right? All right, reciprocal stuff. So let's take the reciprocal. We get cosine. What's the reciprocal of 1? It's just 1. So where are the x values positive 1? Well, there's only one location, and that's where x is 0, right? So that's all you have to do. There's only one solution to this long, messy problem, and that's where the x value is 0, or theta is 0. Okay? One last example. Tangent squared x minus 1, tangent squared x minus 3. All right? This one, you don't have to box or FOIL. You can just treat these as almost as separate problems. So I do tangent squared x minus 1 equals 0. Tangent squared x minus 3 equals 0. So there's no substitution needed on this problem because they have the same trig function. So I can solve it. Tangent squared x equals 1. Square root both sides, right? So I get the tangent of x equals positive or negative 1. Where are tangents 1? Well, that's the pi over 4s, right? So x would be pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Okay? Over here, tangent squared x equals 3, but we've got to take the square root. So we do the tangent of x equals positive or negative square root of 3, right? Think about it. Where do we say the square root of 3 tangents are? Well, that's at the pi over 3 angles. Okay, we need positive and negative, so we're going to need all 4 of them. So we'll list them. Pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Okay? Now, this one has a lot of solutions to it, doesn't it? So in a problem like this, when you have lots of answers, sometimes it's trickier to put it in order. I'm okay if you keep them separated in order. Okay, this one's in order, and this one's in order. So I'm okay if you do that, leave them as separate units. But this does have 8 solutions, so give a heads up on that, all right? All right, that gets through all the examples, and we'll talk more when we get to class about it, so make sure you have questions for me if you have any, all right?